Have you ever wondered why supersonic flight isn't so common anymore? Certainly the technology has advanced to the point that supersonic flights should be the norm, right? But they aren't. And the reason why is simple: the noise. You see, the sonic boom that is created when an aircraft exceeds the sound barrier is cool, but over time it becomes annoying. So much so that in 1973, the U.S. Federal Aviation Administration imposed a regulation prohibiting aircraft from flying speeds beyond Mach 1 over U.S. landmass or territorial waters. And this ban continues to this day. And it's not just the annoying noise that's concerning. A sonic boom has the potential to cause structural damage to any object that it passes over. Just a couple of decades ago, you could fly from New York to London in 3.5 hours and do so in style. Well, that's not the case anymore, but that could be coming to an end soon. There's a new breed of aircraft that aims to reverse the decades-old ban on supersonic flight. And probably the most exciting of these aircraft is NASA's X-59. Dubbed the Quest Project, its goal is to develop a supersonic aircraft devoid of disruptive sonic booms by focusing on sound levels rather than speed. It's being referred to as quiet supersonic technology. But is it even possible? A system for measuring the sound of a sonic boom is referred to as perceived levels of decibels, or PLDB. It's actually sound that you hear, not necessarily the sound that's being produced by the sonic boom. But when the Concorde broke the sound barrier, it produced a sound of 102 PLDB. Anything over 80 can lead to hearing loss over time. And NASA hopes that the X-59 can lower the PLDB to 75. And this number is significant because studies have shown that levels below 75 result in low to no annoyance reactions to sonic booms. To put that into perspective further, the sound of a basketball bounce is 81. But is it even possible to reduce the sound of a sonic boom to an acceptable level? And if it is, how does NASA plan to achieve this?
I want answers!
The X-59 is designed to fly at supersonic speeds while minimizing the intensity of the sonic boom it generates. It features a long, slender shape and other aerodynamic features that help reduce the shock waves typically associated with supersonic flight. In 2016, NASA awarded the preliminary contract to Lockheed Martin to design, build, and test the X-59 as part of its low boom flight demonstration program. And Lockheed Martin gave the responsibility for designing the new aircraft to the engineers at the legendary Skunk Works facility. They are renowned for their legacy of developing cutting-edge aircraft systems that push the boundaries of what is achievable in aviation. Skunk Works has a reputation for solving complex problems quickly, quietly, and affordably, making it a trusted entity in addressing critical national needs for the military. They are responsible for probably the most iconic supersonic aircraft ever built, the SR-71 Blackbird, as well as the F-117 Nighthawk and 11 other X-planes. And although the contract was awarded in 2016, Lockheed Martin has been working on the problem of sonic boom noise for several years. Originally dubbed the C-100, the aircraft went through several design modifications. After being modified, it became the C-435, then the C-506, and then the C-603, and eventually the X-59. In April of 2018, NASA awarded Lockheed Martin with a $247 million contract to build and deliver the new X-plane by late 2021. And by June, assembly was underway with the goal of the first flight being conducted in 2022. And although various types of testing have already been completed, the X-59 has not taken flight as of January 2024 due to unforeseen delays. The X-59, referred to as a low-boom X-plane, is 99.7 feet long, with a wingspan of 29.5 feet. And it's powered by a General Electric F414 engine, which can also be found in the FA-18 Super Hornet. The engine should be able to propel the X-59 to speeds of up to Mach 1.5. And in addition to borrowing the engine from the FA-18, the X-59 uses the same cockpit, canopy, and ejection seat as the T-38 and the landing gear of an F-16. Probably one of the most interesting features, or perhaps non-features, is that the X-59 does not have a forward-facing window. Instead, it has two cameras, one mounted above and one mounted below the aircraft. It's referred to as the external vision system. It's designed to offer performance levels that are equal to or better than the traditional forward-facing windows, ensuring that the pilots have optimal visibility and situational awareness during flight operations. When an aircraft passes through the air at supersonic speeds, it creates pressure waves in front of and behind it, similar to the bow and stern waves created by a ship. As the speed of an aircraft increases, these waves are forced together or compressed, leading to the formation of a shock wave that generates a sonic boom. This boom is a continuous effect that occurs while the object is traveling at supersonic speeds and affects only observers within its path. The intensity of the sonic boom depends on factors such as the size and shape of the aircraft, with larger and heavier aircraft producing more distinct sonic booms than smaller ones. The goal of the X-59 program is to reduce the sonic boom that occurs as an aircraft exceeds the speed of sound. That's all well and good, but how does the X-59 look to achieve the goal of reducing the sound of the sonic boom? The X-59 is designed with a unique shape and advanced aerodynamics aimed at reducing the intensity of the shock waves associated with supersonic flight. Its long, slender fuselage and carefully designed contours help to minimize the effects of sonic booms on the ground. Essentially, the aircraft's elongated fuselage helps generate a shock wave that itself is elongated and rises more slowly, which exerts less pressure on the eardrum, thus lowering the perceived sound of the sonic boom. By designing the X-59 to minimize the sonic boom effect, NASA seeks to make the sonic boom much quieter and more acceptable to communities on the ground. The traditional sonic boom will be replaced by a softer sonic thump. To validate and refine their noise-reducing technology, engineers conducted testing using a small-scale model of the X-59 in a supersonic wind tunnel. These tests involve capturing shockwaves produced by the model using special cameras and sensor arrays designed to visualize and measure their strength and position. The results from these tests have been promising, showing that the shock waves produced by the model align with earlier computer models. This data is critical for NASA to predict and understand actual sonic thumps during future X-59 flights. And furthermore, NASA plans to engage with communities on the ground to gauge their response to the noise generated by the X-59 during flight tests over selected areas. The goal is to confirm that the 75 decibel boom will be acceptable, with the data gathered being presented to the regulatory authorities like the Federal Aviation Administration and other international regulatory bodies. Ultimately, NASA hopes that successful demonstrations of reduced sonic booms by the X-59 will lead to changes in regulations, and those changes in regulations will hopefully lead to new generations of supersonic aircraft being allowed to fly over routes that are currently restricted due to noise concerns. And not only does it look pretty damn cool, but the X-59 represents a significant milestone in NASA's efforts to enable the return of commercial supersonic flight over land. And the data collected from its flight tests will inform future generations and standards for supersonic travel, paving the way for a new era of faster and more efficient air transportation. Wouldn't that be awesome? As mentioned earlier, the famed Lockheed Martin Skunk Works is a primary contractor of the X-59 build. They are most famous for the legendary SR-71 Blackbird that to this day is still the standard in which all other supersonic aircraft are measured. The SR-71's primary mission was to gather intelligence from the Soviet Union, and for decades, it did so with impunity. But despite its successes, that didn't mean that the Soviets didn't make an effort to stop it. In fact, the MiG-31 was designed and built with one mission in mind: to intercept and shoot down the Blackbird. And on one occasion, it almost worked.
Tell us more.
To hear that little-known piece of history, click the screen now. And until next time, I'm Dennis Gill for Revealing History.